Okay, it's 9 o'clock. Let's get started. Welcome, everyone. I hope you had a great first day at NDC Oslo. And thank you for tuning in to my session about event-driven computing with Kubernetes. My name is Jakob Ehn. I work at a company here in Sweden called Active Solution. And I'm a Microsoft MVP. I have a strong background within DevOps, but I also work a lot with cloud computing and preferably Azure, of course. And you have my contact information here, so feel free to reach out after the session on Twitter if you want to talk more about this stuff, as I love to do. So let's get started about what I mean about event-based computing or event-based automation. So when you are developing projects and when you're running projects in production, there are a lot of things going on, and a lot of this stuff is event-based. So examples of this could be, for example, that you're sending a message to a message queue, and you need to respond to that. But I'm also referring to events such as a new container image version is being pushed. Maybe someone pushes a commit to GitHub, or a pull request is approved. So these are all events in the ecosystem around your software development process, really. And in many of these cases, you need to respond to this in various ways, preferably using some kind of automation. So examples of this could be that you typically want to trigger a build, perhaps when a new commit is pushed. Maybe you want to create or tear down a testing environment to run some smoke tests, for example. Perhaps you need to do security scans on a container image. Another example could also be that you need to scale your application up and down depending on the load of the application. So if you're receiving a lot of messages, you might need to respond to that by scaling up and down. And of course, there are many other things that you need to do here. And the topic of this talk is to show you how you can realize this using Kubernetes. And kind of driving the point that if you are running Kubernetes, you have this huge platform which you can use for not just running your application in production, but also to implement this kind of automation that goes on around the application or your systems. And of course, if you have been using, Kubernetes and working around the cloud native stuff, there's a huge ecosystem around this. There are so many tooling available that implements all aspects that you can use here. And I'll be focusing on two different projects that we are using. The first one is called Brigade, which is event-driven scripting for Kubernetes, and the other one is called KEDA, which is Kubernetes-based event-driven autoscaling. Both of these projects are open source and active. And I'll be showing you demos for both these projects, and they are targeting a little bit the different scenarios, of course, but they're both related to implementing event-driven automation. So I'll start with talking about Brigade. And this is Brigade is an open source project from the guys that also built, for example, Helm and Draft. And the main point of Brigade is to chain together containers to create workflows in your Kubernetes cluster. So the idea here is that you have all this functionality available as container images. These might be public container images, or they might be your own container images that you build yourself. So the idea is that you don't have to rebuild this functionality. Instead, you just need some way to use these images and to chain them together to create either simple or complex workflows inside your existing Kubernetes cluster. And Brigade doesn't really require anything extra. You just install Brigade into your cluster and you're good to go. You don't need anything extra. So this will run in any Kubernetes cluster, either on premise or in any of the cloud providers out there. Brigade uses JavaScript to create the pipelines. So the pipelines, that's how you're chaining your containers together. So this is a super simple example of how you're creating what's called a job. And I'll go more into the details later on here, but basically you're creating a job specifying your container images, and then you're telling it what tasks should be run inside this image. And you can run them serially, you can run them in parallel, and so on. So you have a lot of options, but the idea is that you're using JavaScript to implement this pipeline, and you can store this code, together with your rest of the application, or you can store it separately. It really depends on the scenario here. And of course, there will be a lot of integration going on here, and Brigade comes with ready-made integrations, for example, to integrate with GitHub, to respond to any kind of events that goes on in your GitHub repository. Also, services such as Azure Event Grid, Azure Container Registry, and also Kubernetes itself, and many more here. So these are ready-made integrations that are available, so you don't really have to understand the format of these or the APIs here. But in addition to this, there's also what's called a generic gateway, which really allows you to integrate with any kind of API. As long as you can speak JSON over HTTP, you're really good to go. So let's take a look at the architecture of Brigade. So that has this concept of a gateway, and the gateway is what you'll be triggering with some kind of event from the outside. So, for example, this could be a trigger from the outside. For example, somebody is pushing a commit to GitHub, and now the gateway will respond to this by looking up the project. So a project in Brigade is for every type of automation, you're creating a project in Brigade that contains some metadata around this project. And so depending on the trigger coming in, the gateway looks up the project to know what should happen to handle this webhook that comes in from the outside. So the gateway will then translate this into an event and will kick off a build inside your Kubernetes cluster. And inside this build, it will be running then one or more jobs, depending on how your JavaScript pipeline looks like. So you can run them again, you can run them sequentially, you can run them in parallel, so you can really create simple or complex workflows here. So let's take a little bit closer look to a Brigade script. So first of all, we're importing the Brigade library, which will give you access to some of the programming constructs that you're using with the Brigade. And all the logic in the Brigade pipeline will start with you responding to some kind of event going on. So in this case, I'm listening to the exec event, which is a kind of a special event that you can use when you're developing your pipeline. So you can trigger this locally, and I will show you in the demo. But this could be any kind of event. It could be a push event, it could be a commit event, and so on. Inside this event handler, you'll be creating one or more jobs, and each job you'll give a name, which is really a display name that will show up in various logs and UIs. And then you'll give it a container image. So in this case, I'm referring to the Alpine image version 3.8. So this is a public image. But again, this could be any image that is available either publicly on Docker Hub, or it could also be a custom image containing your particular tooling or what have you. So the point is I'm referring to an image here that contains everything that I need. And then I'm specifying a series of tasks here. So what do I need to run inside this container image? In this case, I'm just doing echo, so nothing spectacular there. And finally, I'm doing a job run here, which will just run this task inside that container image. So we can trigger this pipeline manually by using a CLI that I will show you in the demo in a minute. But what typically will happen when you're running this pipelines sort of in production is that you will trigger this from the outside using some kind of webhook integration. So we have either the generic gateway that I talked about. This is what you can use for really any kind of integration. And then you'll trigger this by using either the simple events URL, which is in the top left there, or you can use the cloud events. So cloud event is a standard actually that many of the cloud providers now are implementing, which will make it easier to implement integration across cloud providers really. But both these URLs contains two parts, the project and the secret. So the project is the ID that will actually identify which pipeline should I kick off. And the secret is the kind of an authentication that you need to have in order to actually start a build, to actually allow you to send a trigger into your Brigade pipeline. So either you're using a generic gateway or you're using one of the custom gateways, such as the GitHub, for example. And in that case, that provider will decide how that custom path will look like. So GitHub provider will have a specific GitHub/events, for example, while the Azure Container Registry Gateway has another format of the URL. So let's do some demos around Brigade and see how it actually works, and to show you how kind of easy it is to getting started here. So I'm going to show you how to get started to create and run the Brigade pipeline, and then I'll show you two a little bit more realistic examples. The first one will be how you can implement sort of a super simple CI solution by responding to a commit being pushed to GitHub. And the second one is from a customer case actually that I've simplified a bit, where we're using Brigade to implement part of a pull request workflow, where we use Brigade to clean up our testing environments when the pull request is completed. So let's switch over to demo mode. And all the source code here is available and on the GitHub account, and I'll show you the link at the end of the presentation. So let's start by looking then at how you would install Brigade. I already installed it, of course, in my cluster, but it's really simple. The only thing you need to do is to add the Brigade repository for the Helm chart, and then you're running Helm install Brigade. That's really it. And then you can, of course, add the custom gateways that you want to use, such as the GitHub and so on. And let's take a look what I'm actually running here in the cluster. So just to show you, so this is what I'm having in my cluster, and these are the pods running in the cluster. So the first one too, the API and the controller, that's kind of the brain of Brigade that implements all the functionality. Then we have three different gateways here. I have the generic gateway, which is the one that you're using for the custom integrations. And then I also have the GitHub gateway and the event grid gateway. And I will show you a demo on the GitHub one. And finally, the one called Cached, that's a dashboard for Brigade that you can use to visualize your pipeline and to see what's going on here. And I will show you that. So again, let's take a look at the Brigade pipeline. This is basically what I showed you on the slide, but in this case, I have defined two jobs. So again, I'm listening to the exec event and I'm running two jobs, the hello world and the goodbye job. Both of them are using the same container image, and then I'm just echoing something inside each job here. But you can see the point here. You can really do anything inside here, and depending on the tooling that you have in container image, you can do all sorts of stuff. And of course, one common thing would be to run scripts that are inside the container images. And finally, I'm running this. Here I'm using the run each construct, which is a way of running many jobs sequentially. I could also have run them in parallel if I want to. Then I would use the run all construct. So these constructs are available to me because I have imported the Brigadier project here. Now to work with Brigade, you'll be using the Brigade CLI, and which is called Brig. So you just install that sequentially, and by using Brig, you can now create projects. You can kick off builds. You can watch information about Brigade. So I'm going to now create a new project, and I'm just going to switch to my other shell here. And I already have some projects in my cluster. I have 3 of them that I'll show you demos of. But I'm going to create a new one here. Sorry. So I'm going to do Brig project create. And this will launch kind of a wizard, which you just respond to a few questions, and it will create the project for you. So the first one is to say, is this project a version controlled one, or is it not? So a very common thing to do now is to store your Brigade pipeline script together with your application code, because it typically will do something related to that application. And in that case, I would point it to that repository. In this case, I will just say no to this one, and I'll just store the pipeline separate from any project here. I'm going to give it a name, so I'm just going to call it Jakob/demo. I'm not going to add any custom secrets here that I could use. This could be information that I would need later on in my pipeline to, for example, communicate with some service or something. However, I am going to add the generic gateway secret. So this is a secret I will use to actually call this pipeline from the outside using the generic gateway. So I'm just going to give it the secret of super secret. And that's really it. And the final question is to point out the name of the path to my JavaScript pipeline here. And that's it. So now Brigade has created a project for me. Let's list them again. Oops, sorry. Brig project list. So you can see now that we have an additional project here with an ID. And if I want to, I could now get some information about it by doing a project get. And actually this information, this metadata here, is actually stored as a secret inside Kubernetes. So you don't need anything extra here, it just gets stored right away there. Now, okay, so we have this pipeline, and let's run it. And I can do this now locally, kind of in a developer mode. I can use the brig run command here. So this will actually call the exec event handler in that script. And as you saw before, I have one of those. So let's do a brig run here and see what happens. So what will happen now is that the Brigade will parse the JavaScript pipeline, and it will then, for each job, it will create a new pod and running those tasks inside that pod that I specified in my pipeline. And you can see some detailed information here, but the gist of it is that here you can see that it's creating a pod for the say hello, and here it's creating the pod for the say goodbye here. And so now actually my pipeline was executed in the cluster by me just running the brig run. If we take a look at the pods here, we can see now that we actually have 3 pods that just completed. The first one is the Brigade worker pod. That's the pod that actually executed the pipeline and triggering my functionality, my jobs. And then you can see 2 pods here, say hello and say goodbye. So this now then correlates to the jobs that I specified here. So each of these were executed inside that pod. Now we could of course get logs using the Kubernetes commands. So we could get the logs and so on. But there are two UIs available for Brigade, and I'm going to show them now. So the first one is the cache to dashboard. So if I'm typing a Brig dashboard, it will now show me a UI. And so this is a pretty nice UI. It will show me all my projects, and you can see that the Jakob demo one was executed recently. And now I can drill down into this project to see that okay, we had one build that was triggered by the exec event, and if we drill down into that one, we get a little nice UI specifying the workflow here. We get the logs from the pipeline itself, and we can also drill down into each job here and actually see information about that particular job, and in this case also see the output from it. So this is of course very relevant if you're troubleshooting something. You can go in here and see what's going on here. You can also of course see running jobs here to see where in the pipeline they are currently. So this is a nice UI that you can use. There's also a console-based one. It's called Brigade Term. So this is really the same functionality, but you get it straight inside your console instead. So you don't need to head over to a browser. So this is a little bit more hardcore perhaps, but again, you can see the same information here. You can see the projects. I can drill down and see really the same information here. So again, I can drill down all the way down and see the outputs. So two options here to see what's going on and to troubleshoot Brigade pipelines. So, okay, now we have created a Brigade pipeline and we executed it sort of manually using the Brig CLI. But the common thing to do now is to trigger it using some kind of webhook from the outside world, so to speak. And to show you how that can be done, I'm going to use Postman here. And so I have a custom domain name from my Kubernetes cluster. So this is the Brigade Demo.en.nu. But this important part here is the second part here. So if you remember from the slides, we have the /simple events v1. That's the URL you want to use to make a request into the generic gateway. And then to identify and authenticate to the pipeline, we need to specify the project ID and also the secret. So the project ID, we can get that again by listing the projects and just grabbing it here. So I'm just going to replace project ID here with that ID. And the other part is the secret for the generic gateway. And that's the one that I said to super secret. So let's call into this one. And you can see that it responded to success, build created. And if we are fast, we might be able to see what's going on here, but it's already executed. So in this case, it called the simple event here. And you can see that executed. So you can see the old one here, and then you can see the new event here. So again, you can drill down into here and see the details. And to show you here, if you go back to the pipeline, we have the event handler for exec, but a bit further down here, I also have the event handler for simple event, which in that case, I'm just doing a simple echo straight away here. So again, this is what you would do to implement your integration. You would if you're using generic gateway, you just need to listen to the simple event, and then you can call it into it using a webhook, and that's really it. So very, very simple. So let me show you a little bit more advanced example where we are implementing a very simple CI system, so to speak, and integrating it with GitHub. So let's take a look at this pipeline. And again, all of this is available on my GitHub repo. So you can see in this case, I'm listening to the push event. And this event is created by the GitHub generic gateway. So it will handle the things like translating it from the GitHub webhook API, and it will translate it into simple events and also containing information that I can use inside this event handler to make it easy for me. And after this, I am creating 4 jobs. And you can see that the first 3 ones are about compiling and testing the application, which in this case, I'm using the .NET Core Docker image from Microsoft, the 3.01. And you can see now I have the compile, test, and publish jobs. And inside this, I'm basically just running .NET Build, .NET Test, .NET Publish. Of course, I could have done this inside one job, but this is more to show you how you can make more advanced scenarios. And the final job, I'm using another container images for sending a message to Slack. So this is just one of the images that are available, the Slack notify container images. And then I'm just passing information here. So the message, title, and so on, and also a secret. So if you remember when I created my project, I could also have added custom secrets. And this is a good example of it. So to be able to send call a webhook in Slack, you need a secret. So when I created that project in Brigade, I specified that secret here, and I can access it using the the parameter that gets sent into this event handler, the P parameter here. And then I'm just running all this job sequentially. So I'm compiling, testing, publish, and then doing a Slack message. Okay, so this is the pipeline, and of course I already created this this project. So I have this Jakob Ehn /Brigade app. That's the project, and it points now to my GitHub repository. So let's trigger a change now. We're listening to the push event. So let's head over to GitHub. And first of all, I just want to show you how I set up the connection here. So one way of doing this is to just go to the webhooks. And you can see here now that I specified the webhook, and I'm pointing it to my cluster, and then /events/GitHub. So that's the format that the GitHub gateway is listening to. And if I edit it, you can also see that I'm actually having a secret here, and that's the secret that I specified when I created the project, and that's how I actually authenticate to my Brigade pipeline. So not anyone can just send events to this URL, of course. So to test this, let's make a little change. So let's add something to the program CS. Let's just add a comment here and commit it straight away. So what should happen now is that let's go back here and let's do a Brigade term. So now you can see that my Brigade app pipeline is already running here. And if I drill down into it, you can see now that it was triggered by the push event. And if we go inside here, we can now follow the pipeline as it compiles, tests, and publish this project. And you even get a little nice UI up here showing kind of the progress. And down here, you can then again see the status of each job. And again, you can go into each job. In this case, I'm looking at the compiled job, so I can see the output from the compilation phase here. So super simple. And of course, I'm not really saying that you should implement your own CI system using, I mean, there are plenty of CI systems available, but this is to show you how easy it is to build integration. And if you're already using Kubernetes for your application, it takes very little to use it for this kind of infrastructure around it as well. It just makes a lot of sense. And let's actually show you that the last step was to publish to Slack. And just to show you here, I got this Brigade demo message going down here that says sample app built and tested successfully. So it worked out nicely. Okay, so that was how you can integrate with GitHub. And you noted also that the Brigade took care of downloading the source for me. That's done automatically. So I can just refer to the source code as is. So just stepping into the source directory and then running commands from there. So I don't need to handle anything of that. Brigade does that for me. So the final demo for Brigade is to show it's a customer case where we are using Azure DevOps and the Kubernetes, and we have a workflow here for pull requests. So let me just show you this. This is a simplified version of it. So this is the release pipeline that we're using, and the idea is that for every pull request that's being made, so this is ongoing work, we are creating and deploying the application into a new namespace in Kubernetes. So every time a developer makes a pull request with some new functionality, this pipeline will then be triggered. It will create a new namespace in Kubernetes cluster and deploy the whole application to it. And then we can run tests on it, and we can have stakeholders going into it and testing it. And that all works very, very nicely. But then we need a way to clean this up. So what we want to do here is that when the pull request is completed, we want to make sure that everything is deleted. So we want to delete the deployment and remove the namespace. Otherwise, we would pretty soon fill up our cluster with old PR implementations. And turned out that the Brigade was a really good case for this. So let me show you the pipeline here. So this is a more, of course, a little bit more complicated, and I'm not going to drill down into all the details here of how it's actually doing. So just the overall point here is that we're using Helm to deploy. So this pipeline now consists of two things. We are using Helm to delete the release, but we also need to delete the namespace in Kubernetes, and we can't do that using this version of Helm. So we're actually running another job where we're using the Kubernetes CLI, the kubectl, and deleting this namespace. So again, you can see up here that these are the images that we're using. So there are already ready-made container images that let us use Helm or let us use the kubectl. And this is just one of those examples. So there's a lot of functionality out there. And let me show you how this works. If we go back to here, I'm going to show you Helm ls here to see what's inside my cluster. And you can see that we have one release here called sample web app 116. And this is actually now a pull request that I created yesterday. So you can see that the 116, we're just taking that from the ID of this pull request. So this pull request was built and deployed, and I have approved it. So the idea is now that we have tested it, everything looks good. So we want to complete this pull request. And when this happens, we want to make sure that we're cleaning everything up here. And before I'm going to hit complete here, let me show you how to, again, how do you actually connect Azure DevOps in this case with the Brigade pipeline? Well, it's quite simple. In this case, we're using service hooks. So very similar to the webhooks in GitHub. We're using service hooks here instead. And let's go inside this one. So in this case, I'm listening to the pull request updated event, and I'm specifying the source repository. And in here, this UI is a little bit stupid, but here you can see the full event, the full URL. And again, using the simple events. So this is not any, I'm just using the generic gateway here to implement this. And again, specifying the ID of the project and the secret for the Brigade project. That's all it takes, really. And so let's complete this pull request and see what happens. So this should now trigger an event. So let's go back into, I should do the Brigade dashboard. So now you can see that this PR is now running, and it was triggered by that pull request event. It was completed. So now it's going to run my two jobs and cleaning up deployment and also deleting the namespace. So you can see now that it's deleted the release and it's about to delete the namespace as well. And that means now if I go back, we can also look at the logs from here. So in this case, I'm running the Helm container, and it says release sample web app 116 was deleted. So again, if I go back to my terminal here and do a Helm ls, I can now see that the sample web -116 is now gone, and also the correlating, the corresponding namespace is also gone. So this was a very good example for how you can use Brigade to kind of tie your integration nodes together. We could have implemented this in a lot of other ways, of course, but it just makes a lot of sense when you have everything running in a Kubernetes cluster, and to use that cluster for these types of integrations as well. So we don't need anything extra here. We can just run it inside the cluster. And that's really one of the main points here, that you use your existing infrastructure in Kubernetes to run everything in, so you can kind of consolidate your infrastructure by using Kubernetes. All right, so that was the first part of the demos, which were around the Brigade. And so the second part, I'm going to talk about the project called KEDA. So again, this is also related to events, but this is related to scaling, which is a very common thing to do when you get a lot of events. If you have event-driven applications based on queues or service buses, and you start to get a lot of a lot of messages, you need to scale your application up and down. So KEDA is an open source component for event-driven scaling in Kubernetes, and it allows you to scale from 0 up to thousands, or how many instances of your applications that your cluster allows you to run. And the 0 part here is actually a bit interesting because, as I will mention later on also, Kubernetes has already auto-scaling built in, but it can't scale from 0. You need to have at least one instance running before it can scale it, while KEDA actually allows you to scale from no instances, which is actually very interesting in various cases. But also, KEDA doesn't replace the Kubernetes auto-scaling, it actually uses it. Because the main point here is that for the Kubernetes auto-scaling is built, it uses metrics such as CPU and memory consumptions, which works fine for some types of application to scale. So if you have a lot of load on your web app, you can scale it out. But if you're looking at event-driven applications, where you have things like service buses or message queues, and you start getting a lot of messages on that message queue, that doesn't really cause your application to consume a lot of CPU. It will just continue to pull that queue, one message at a time, and you will be building up a huge queue there. So what you want to do here is that if you see that you have a huge message queue lying there, to make sure that you can scale up your application to consume those messages faster. And this is exactly what KEDA allows you to do. And it supports a lot of various event sources, like the Azure event sources, the service bus or the storage queues, but also a lot of other ones like the AWS or Kafka or RabbitMQ and so on. Also, what KEDA allows you to do is you can run and scale your Azure functions in Kubernetes. So Azure Functions is, of course, a PaaS service that allows you to very easily implement small functionality and small integrations and just run them in Azure. And Azure can also then, it will instantiate and also scale them appropriately when you start to get load. So the Azure Function is a great runtime. It's a great programming environment to implement this in. But there are actually cases when you might want to use them, but actually run them in Kubernetes, because that allows you to, for example, run things on premise or behind firewalls, and a few other scenarios. So Microsoft has the whole Azure Function runtime is available as a Docker image from Microsoft that you can use. And so you can just package your application inside a Docker image and then deploy it into Kubernetes. Now, the big thing you're missing when you do that is that how would you scale it? If you're running Azure Functions in PaaS, you'll get scaling automatically. But if you run it in Kubernetes, you don't really have anything to scale it for you. So this is what KEDA brings to the table. So it will actually allow you to deploy your Azure Functions into Kubernetes and scale it based on various event sources again. So I will show you demos on both these things. So again, KEDA doesn't replace the horizontal pod autoscaler, which is the scaling component of Kubernetes. It adds on top of it, and it supports a lot of various event sources and have scalers for them. So a scaler is the component that actually will monitor a particular event source and scale your application up and down. So you can see that the list of event sources is long and it keeps growing. And the KEDA project actually reached GA 1.0. Well, now it's I think it's 4 or 5 months ago. So it's a healthy and a thriving project in the open source world. So if you have been working with Kubernetes, you might know about the horizontal pod autoscaler, which is a component you install and you configure it to scale your deployment, for example, based on CPU. So you can say things like, if my pods consume more than 80% CPU, I want you to scale it up to a particular amount of pods, so I can handle that load better. But again, this doesn't really work very well for event-driven applications. So let's take a look at KEDA scaling. So a typical case here that you have a deployment with a pod, and then you have some kind of queue somewhere that you are monitoring. So you're sending and you're receiving messages from that queue. So what you do then is that you configure your installing KEDA into your cluster, and you configure it to use a scaler for that particular type of queue. And that scaler then contains something called a scaled object. And that's the definition really of which queue to monitor and how to scale your deployment. And I will show you the details right up after this. So you configure it to monitor the queue, and based on the metrics for that queue, typically the message lengths, how many messages are currently on that queue, it will then configure the horizontal pod autoscaler appropriately, and the API will then scale my deployment up and down, which then allows me to consume messages from that queue faster until the queue is empty, and then I can scale down again. So the scaled object looks like this. This is a custom resource definition, CRD, in Kubernetes, which is a way to extend Kubernetes. And there are a few main parts here. First of all, we have the scale target ref. This is where you specify which deployment do I want to scale using this. So in this case, I have a deployment called order processor, which is the component that actually receives and processes messages from the queue. So that's the one I want to scale up if I see that I have a lot of messages coming in, because that allows me to consume them faster. The other one is the trigger part, and depending on the type of event source that you're using, this is going to look a little bit different. In this case, I configured to use the Azure Service Bus, and then I specify the name of the queue, and I give it the connection string, and I'm specifying the queue length to be 5. So that means that if the number of messages reaches above 5, that's a signal then for KEDA to say that now I want to scale up my deployment because I'm getting a lot of messages and I want to make sure that I consume them within a certain amount of time. So I want to scale up. And the last part here is where you configure how that scaling should, the boundaries for that scaling. So in this case, I'm saying that I want to always have at least one pod, one replica running, and I want you to scale up to 10, to the maximum of 10 replicas. So this is depending on your cluster, how much resources you have available, and so on. And then you have polling interval, which is how often should the KEDA scaler check the queue in this case, so every 5th second. And then you have a cooldown period which specifies that when the messages are processed, how long should we wait before scale down? And this is something that you need to play a little bit with to find the right numbers here, because it really depends on the characteristics of your applications and the characteristics of the traffic and the load here. But you typically don't want to cool down immediately because then you can find yourself bouncing back and forth if you start getting messages again. So I'm going to show you two demos with KEDA. And the first one is how you can scale the application based on the queue length of an Azure storage account. And the other one is how you can create, deploy and scale an Azure function with KEDA. So these are the two main functionalities, areas of KEDA. So let's go back to the source, and I'm actually going to switch cluster here because I have KEDA running in another cluster here. So let's see what I'm having here. Let's look at the deployments in that cluster. And you can see I have 2 Kubernetes deployments in my cluster. I have order web, which is a kind of a sample app that will actually show me. I use this for this particular demo, which will actually show me the length of the queue. Just makes it a bit more visible. So that's running there. But then I have the order processor here. And what's a bit special about this one now is that you can see that it's actually the deployment is there, but there's no pods running. So there's 0 pods running, which is kind of interesting now because again, Kubernetes doesn't allow me to auto scale a deployment that doesn't have any pods because it needs something to get metrics from. So let's take a look at the scaled objects that I already deployed. So this is very similar to the one that I showed you before. And the main difference here is that I actually specified the min replica count to 0 here. That's why I'm having currently 0 replicas here. So this is actually kind of cool, which means that you can have all these deployments ready, but they don't need actually have to consume any resources because you can have 0 instances running, and then you can have KEDA scale them up on demand. So to show you this demo, I will now, sorry. Like this. So I'm just gonna do a little screen magic here because I want to show you when the scaling is going on, what actually happens on both sides, so to say. So let's do a get deployment here. So I'm gonna watch this deployment now. I'm gonna follow it by using the -W option. So now we can see how many what happens when we start scaling this. So again, nothing happens. We have 0 instances and we don't have any messages on that queue. So to run this demo, I'm gonna now send a lot of messages to my storage queue. And to do that, I'm gonna run just a sample application called the order generator and specify I want to send 300 orders here. I'm going to start sending a lot of messages to that queue, and let's see what happens. So now it starts running. So now you can see that the queue is building up here on the left side. It's going to go up to 300. On the right side here, you can see now that almost immediately KEDA scaled it up from 0 to 1 instance. And then it's going to continue to look at the length of this queue. And as long as it's above 5, and depending on how much above 5 it is, it's going to keep scaling up my number of processes here until it reaches my maximum limit. So you can see now I'm having 8 replicas running, and you can see now that the queue length is now starting to decrease faster. And I think it will even scale up to my maximum amount, which is 15. So now you should see now it's running up 15 instances of that pod. And you can now see that the queue length is now decreasing much faster. So there is a kind of a sleep job going on there. So to kind of simulate some work to make it a little bit more realistic. But you can now see that the queue length is decreasing fast because now I have actually 15 instances of my order processor consuming messages from that queue. And in a few seconds, the queue will go empty. And now in a few seconds or around 30 seconds, which is my cooldown period, KEDA will now scale down that deployment because there's no more messages coming in now. And again, you need to configure the cooldown period a little bit because it might not be realistic that you get a lot of messages and then you don't get anything. So you need to kind of configure it. So now you see after around 30 seconds, KEDA scaled it down to 0 instances. So again, if we do another get deployment, you can see that I have no instances running at all here. But again, if I start sending more messages, the same thing will happen now. The queue will build up, and the number of instances will also scale up appropriately. So that's kind of the core part of KEDA. And as you can see, the only thing I needed to do was, of course, I need to install KEDA itself, which is I didn't show you, but this is very similar to to what I showed you for Brigade, we're just using Helm. So we're adding the Helm chart for KEDA core, and then we're installing KEDA. So we get these components. And then I just need to create these scaled objects to configure KEDA to know, okay, which deployment should I scale and where should I get the metrics to scale that deployment. That's all it takes, really. So the other thing that KEDA also brings to the table is the option to scale, to actually run and scale Azure functions. So it's really the same kind of functionality, but it opens up this possibility of working with Azure functions in your cluster. And so I mentioned one of the reasons for doing this is that it allows you to, for example, run Azure functions on-premise behind firewalls in your cluster. Another thing that actually is pretty nice is that I see a lot of cases where customers are adopting Kubernetes or perhaps AKS, and they have this whole way of packaging and deploying their container images. But then they also add Azure functions, because Azure functions is a very powerful way to implement certain type of integrations or API endpoints and so on. So they kind of sprinkle Azure functions outside the cluster, and the problem with that is that you get another completely different set of packaging and deploying and monitoring those components, because they're running outside, they're using PaaS. So it causes a little bit of friction there, that you have your core part in Kubernetes, but then you have all these other parts running outside the cluster. And that's actually, I think, it's a pretty good reason to still continue working with Azure functions, but you can instead deploy them into Kubernetes and then deploying them in the same way. So let me show you how this works. So I'm going to create an Azure function from scratch, and I'm going to use the tooling in VS Code to do it. And I'm going to select the queue trigger here, which means that this function will be triggered when something is sent to a queue. Just going to accept the defaults here. And I already have a queue available, which is called the KEDA queue. And let me select that storage account. So this is just the standard Azure function tooling in VS Code. And so now I get a Azure function here that will be triggered by this queue. And I'm just going to stimulate some work. I'm just going to add sleep. Otherwise it will go too fast. Okay, so that's my function. So of course, if I want to now, I can run this locally by using the func start tooling, which is the way that you're developing and testing your functions locally. So we just verify that it actually works. So you can see now that it's running, and it's basically waiting now for something to happen in my storage queue. So this is the storage account that I configured my function to listen to. So let's go to the KEDA queue that I have here and just send a test message. Hello, NDC Oslo. And send it, and go back here. You can actually see now that it immediately consumed that message and logged the output here. Okay, so that's nice. That's the basic Azure function, and the typical thing to do now would be to publish it to Azure and just run it there. But instead, I want to run this inside my Kubernetes cluster instead. So to do that, I need a Docker file to create this Docker image, and I can create it easily by running func init and then pass in the Docker only, because I already have the project. I just want to add the Docker file to it. So the tooling here will now analyze my project and try to create the correct Docker file. So this is the Docker file, and you can see that it's using the .NET Core SDK for the build part, but then it uses the Azure function .NET image, which now then contains the whole Azure function runtime. And that's what actually allows us to run Azure functions inside a Docker image. And Now to build that image and publish it, I can actually do that. I could use the standard Docker tooling to do it, but I can also use kind of a ready-made command here. So let me run it and I'll explain to you what happens. So now I'm using the func Kubernetes deploy and I'm specifying the registry. This is where the container image will be pushed. And I'm specifying, so what you can see what happens now is that it's actually running Docker build. That's the first part. So it's building the Docker image locally. And the second part will then be to deploy it to my container registry, which will then allow me to run it inside my Kubernetes cluster. So this shouldn't take too long. And when that image is built, it's going to publish it to that. But you can also see some other parameters here. And those parameters, you can probably recognize them from the KEDA, from the ScaledObject. So this tooling now that comes with KEDA will actually not just publish and deploy the application. It will actually also configure KEDA for me. It will create the scaled object for me, which then allows me to automatically get scaling for that component. So now you can see that the application was built and pushed and also deployed into that cluster. So now I have a new deployment here, get deployment. We can look at my deployments. We can now see that I have an additional one called AssureQ function demo. Again, you can see that it actually has 0 instances running. But what it also created was the scaled object. So I can do get scaled object. You can do it like this. So this is the scaled object it created for me. You can see this is the same thing basically that we did before manually that I showed you. This was now created automatically for me based on the parameters that I passed into that tooling. So here are the information around scaling, the scale target ref that points to my deployment, and also the triggers that points to the web jobs to my KEDA queue here. So this was all done automatically for me. And so let's verify that it works by looking at the deployment. Sorry, get deployment. So this is called AssureQ function demo. So let's follow that deployment again to see what happens. And now in this case, I have a simple script that will just send a lot of messages again to that storage queue, just to test it. So it's going to send 300 messages. I'm just going to run that. And again, let's just see that it actually starts to send some messages. There you go. And let's take a look at this deployment. And you can see again now that it's already starts to auto scale my Azure function. So, to summarize this allows you now to use the standard Azure function tooling that you already, love and use. But instead of just deploying it to POS and have it run there, you can now package it into a Docker image very, very easily. And you can have KEDA implement the scaling for you, because you would not get that otherwise if you just deploy, package it into container images and deploy it. You can do that, without KEDA, but then you lose the scaling part of it, which of course is very important for using Azure functions. So that's about it. That's what I wanted to show you guys. And I just want to finish up with showing you the links to both the Brigade and the KEDA projects, which are open source. You can follow me along there. And the demo code is available on my GitHub account, /Jakob Ehn /Brigade KEDA. And let's see, actually, I've got a question here from Stefan. With HP now getting 0 scaling capability built in, I'm wondering whether KEDA still makes sense for a non-job use case, or whether I should rather work on getting the queue metrics directly into the normal metric store. Let me think of it. I'm going to answer that question in the Slack channel, because I'm out of time here. So I don't want to steal time from the next speaker. So I'm just going to finish here and say a big thank you. I'm glad that you joined my session, and I hope you have a great conference after this. Thank you.